Wait, we should be in maths.
Hello and welcome to A-Level Maths. First we're covering Core 1. Now beginnings of Core 1 are about linear graphs. So there is linear graphs and equations, finding the equation of linear graph, problem solving linear graphs, and simultaneous equations with linear graphs.
Revision from GCSE, a linear graph is really just a straight line graph, and the equation for any straight line is y equals mx plus c, where m is the gradient and c is the y-intercept of the line.
Now if we look at the graph here, this point is the y-intercept. So if we go for an example, we know that this point is 2 and this point is 3, 4. As this is the y-axis, we know it is 0, 2. So now we're going to work out the gradient. What Wayne is now doing is delta y over delta x, and what that means is the change in y over the change in x. So if you look here, the change in y is 2, so it's 2 at the top, and the change in x goes from 0 to 3, so it is 3. This makes a gradient 2/3, and that is it.
That should be a revision of your GCSE. Now let's get on to some real maths. And now on to midpoint and length of a line. Firstly, I'll go through the midpoint of a line. What we have here is a nicely drawn graph that goes from point 2, 3 to the point 5, 7. And all we've got to do, quite simply, is work out the middle coordinate.
Okay, what Wayne's going to do is he's going to write on the board and I'm going to run through what he's doing. So the first steps you do is you need to find the first coordinate, then it's at this midpoint. So you add x1, 2, and x2, 5, and divide this by 2. Then for the second half of the coordinate, the y, you add y1, which is 3, and y2, which is 7, and then divide this by 2. Then you just simplify out the brackets, which makes it 3 over 2 as the x-coordinate, and the other half will be 5. And that's the midpoint of this line.
And it's quite simply, just write it in its coordinate form. Now, we have an identical graph here, exactly the same point, so let's go ahead and put them on. 2, 3, and 5, 7. So this time, we're going to work out the length of the line. So trim. Firstly, what he's going to do is going to divide this line up, as you'll notice, into a right-angled triangle. Then from there, you can simply do Pythagoras. A squared plus b squared equals c squared. Now a squared is the change in x along the bottom. 2 to 5 is just 3 units, so a squared, 3 squared, plus the second, which is the change up here from 3 to 7, so 4 squared. 3 squared plus 4 squared is 25, root 25 is 5. That is the length of the line.
Level up. Now on to parallel and perpendicular lines.
We have here 2 parallel lines. What does that mean in terms of this equation?
Well, Wayne, it means that m, their gradient, is equal to both of their lines. But what does that mean about the lines?
It means that if these lines go on infinitely, they will never intersect. In other words, m1 equals m2.
And that pretty much sums up parallel lines.
Now on to perpendicular lines. Perpendicular lines are when two straight lines intersect at an angle of 90 degrees, as illustrated here. But what does that mean in terms of our gradient there? M1, the gradient of one line, is the reciprocal of the gradient of its perpendicular twin. So M1 equals negative 1 over M2. Another way of saying that, which perhaps makes it much easier, is M1, gradient of one line, times M2, the gradient of the other line, equals minus 1. Now on to the next part, simultaneous equations.
Now, there are two main ways of solving simultaneous equations: the equating coefficients method and the substitution method.
I'm going to go through the equating coefficients method first. Basically what we have here is two equations for two different lines, and we've been told they intersect at one point. We simply have to find out the coordinates of the point of intersection. Triv will talk you through what I'm doing while I'm doing it.
Okay, the first thing we're going to do is make the equations look the same. So he's going to move minus 3x over the other side by adding 3x to both sides. Makes it 3x plus y equals 7. Now, the coefficient of an equation, if you didn't know, is a number before the x or y value. Equating, make them equal, so you need to make one of these equal. y is times this equation by 5, being 15x plus 5y equals 35, which makes it equal to this 5y. And then you just simply take away one from the other, making 13x equals 26. And that makes x equal to 2.
Now this then goes into one of your two initial equations. You substitute x in. I'm going to do it for this one because that looks easier to me.
So you substitute it in, so y equals 7, take away 3, open bracket, and 2, which is your value for x. So you simplify that, y equals 7, take away 6, so y equals 1. This gives the coordinate of intersection as 2, 1.
Now Triv will go through the other method and I'll talk about what he's doing while he's doing it. So this is the substitution method. We know already y equals 7 minus 3x. Well, if that's what y equals, then that y must equal that. So you get 2x plus 5 lots of y, 7 minus 3x, equals 9. The next step, quite simply, just expand out the brackets. We get 2x plus 5 times 7, 35. 5 times minus 3x is minus 15x. Be careful of your positives and negatives in these sorts of questions. It's quite easy to perhaps trip up a bit. Now, simplify it all down. You've got 2x minus 15x is minus 13x. You've got 35 on this side, 9 on that side. Take it over, you've got minus 26. So x equals 2, which is good news because that's what we got here.
And then you simply do what we did last time, put it back into the equation, find the y value, so we'll do that again.
That's right, exactly the same in both the methods. Once you've found one out, you simply put it back into the equation, as we did here. And the y, 7 minus 3 lots of 2, 7 minus 6, y equals 1. The coordinate again, 2, 1. Now we're going to run you through a question. Test yourself, page 21, question 6 of that book. Triv, could you read me part A, please?
1. Line L has the equation y equals 6x plus 1. Part A says, give the equation of the line through point 1, 0, parallel to L.
So what is the question really asking us to do? It's given us the line L. This could just be a line. It's got this equation. We know there's another line parallel to it that goes through this point. Well, what does parallel mean?
It's a huge hint, and it's telling you that m on both equations, the gradient will be equal.
The gradient in this line, as you can see, is 6. So in the line we're trying to find out, it's going to be 6. So what don't we know from this, Triv?
Well, we don't know what c is, so that's what we need to work out.
So what we've got to do is substitute in the y, the m, and the x, which we know from the question, to find out the plus c. So let's do that, shall we?
Okay, well in this point, y is 0, so 0 equals 6 times 1, nice and easy, 6 plus c. So then we find what c is, we're taking away 6 from both sides, and that makes 6 equal to minus c.
So now let's write out the equation of the line we found in the form y equals mx plus c. Y equals 6x minus 6. It's as simple as that. Now there's a part B to this question. I think we should ask Triv to go through this one. So I'll read out the question. Now, line L has the equation y equals 6x plus 1. Part B says, give the equation of the line through coordinates 3, minus 1, that is perpendicular to L. So again, what we have is we have this equation of a line, and we know it goes through this point, and the clue again in the question, it's perpendicular. So the gradient of the new line is the reciprocal of the old one. M2 equals minus 1 over M1. M1 is 6. So the gradient of the line we're trying to find out is going to be negative a sixth. Now, again, we know everything but the plus c. So what we're going to do is we're going to work out the plus c by substituting in what we know again. So this time, y equals minus 1, m minus a sixth times the x, which is 3, plus c. So now let's work that out. We've got minus 1 equals minus 3 over 6, or minus 2/3. I'll take minus a half, plus c. So c must equal minus a half. Now let's put it in the form y equals mx plus c. We have y equals negative a sixth x minus a half. As you can see, I got a bit tripped up with the fractions there. Just be careful when you get these questions. Negatives, positives, all the fractions, just be aware. Wayne and James Drevette.
Linear graphs and equations.
So Triv, what have we learned during chapter 1 of core 1?
Well, Wayne, first we covered line graphs and what a line equation was, most original GCSE.
It was the y equals mx plus c, just summed that up, didn't it?
And the gradient, c, y-intercept. We moved on to
Length of the line and midpoint of the line.
Yeah, we did
that. So midpoint x1 plus x1 over 2, and then y1 plus y2 over 2.
the line Pythagoras, a squared plus b squared equals c squared, making it a triangle.
I think we moved on to parallel and perpendicular lines next.
Yeah.
So parallel lines, gradient's the same. Perpendicular lines, m1 is the reciprocal of m2. That basically sums that up.
Yeah.
What do we do next?
Spontaneous equations.
Substitution and equating coefficients method.
In substitution, you just put, I think, one of them equal to either y or x, substitute it in, and then work it out from there.
Equating coefficients, you just make the coefficients of either the x or the y the same, then cancel it out, substitute back in what you've made. And I think we went through a question after that.
We did, yeah.
Just ran through a question. If you have any more questions that you want us to run through in a video, just put it in the comments below and we'll try do it for you. I think that sums up chapter 1.
Yeah.
It's Wayne Lack and James Trevette.